Okay guys, the lesson target today, student will be able to find the arc length of smooth curve. Another thing is find the area of the surface of revolution. Previous semester we are looking for the volume a lot, but this time we're going to find area of the surface as well. For before looking for the surface, we have to know about the formula for arc length. Okay, let's look at the formula for arc length. Over here, find the length of curve. The side is integral a to b square root of 1 plus f prime x, the quantity square dx. Let me prove that way so you can easier to understand. Actually, you will going to memorize that formula, but first of all, let me explain a little bit of that. So, just assume is you have a curve for that. It's really smooth curve. But even though if you are really zoom in that, zoom in side, you will see the straight line obviously, right? So let's assume to have we have a triangle in here with the straight line. After zooming it up the smooth curve, we have dx, dy, the hypothesis is ds. So by using the Pythagorean theorem, we have ds squared equals dx squared plus dy squared, right? So to get rid of square, I'm going to have positive square root of dx squared plus dy squared. From now, I'm going to integrate both sides. So we only get s in this time because one integral, one derivative make you pang. So you only get s in this time. So integral square root of dx squared and dy squared. Now I'm going to have dx squared over dx squared, which is just 1, so we can have that inside of the square root of that. Okay, so let's think about this and this separately. Now I'm going to distribute only the bottom of dx squared here to here. So which makes we get 1 for the first term. The second term, what we get? dy squared over dx squared. But on the top of the dx squared, let's get out of that square root. That we only get 1 dx, since that one was inside of the square root, right? Okay, now we all have that. So let's simplify a little bit of that. S is integer a to b square root of 1 plus, that is dy over dx. You can think about f of x, right? So f prime of x, because we are derivate that. So f prime of x, but wait a minute, we have square and top and bottom. So make the quantity square and don't forget to put d of x in this time. So of course, to applying that formula, you must get something f of x as a function, and also one of the interval for that. So let's go to the next slide so we can see another example for that. Well guys, let's look at the definition of arc length again, looking at the formula. There is one difference between respecting to x and respecting to y. Let the function given by y equals f of x in here. But here, if you have x equal to g of y, In that case, your interval, you have to put the y values of that. In this case, you have to looking at for the x values when you are substitute your interval of x. Of course, if you having for function of y equals f of x, all you need to do is derive first and then square it and then set up for dx in this time since we are respecting to x. But when you are respecting to y, you have to set up dy for that time. Which means you have to looking for x equals g of y. 이때는요 y에 대한 관계식이 필요합니다. dy로 셋업하세요. 얘도 y 값에 y축에 있는 y에 해당하는 구간이라는 점을 명심하셔야 됩니다. 그럼 let's take a look at another example for that so we can easy to understand. Let's go. Okay, let me write down the example. Find the length of y equals 2x 3 over second power plus 1 from x equals 0 to x equal to 1. First of all, the important thing is you have to think the S formula. The arc length formula is integer a to b square root of 1 plus f prime x, the quantity square dx. From our memory, so if you know a to b in here, x to 1, so 0 to 1, square root of 1 plus, we need f prime first in here, so let's derive y, then 2 have there, and 3 over 2 drop out, and x, take minus 1, so we will get 1/2. So if we simplify that, we have 3x to the 1/2 power. But this position here, we need to square it that. So y prime square is that squared. So 9x. So let me substitute here for 9x dx. So how could you integrate that? You might think about processes. I'm going to use the u sum. So let me put u is 1 plus 9x. So du is 9 dx. So dx is 1 over 9 du. And also since we are using to use substitution, our interval has to go up here. So my new interval is 1 instead of 0. So my 1, if I substitute for x, my new u of interval is 10. So I have square root of u. Instead of dx, I'm going to have 1 over 9 du in here. Since square root of u is u to the 1/2 power, if I add 1 here, I'm having u to the 3 over second power. So simplify over here. I still have 1/9 here. I has to have 2 over 3 out and u to the 3 over second power, and using fundamental theorem of the calculus, I has to put 10 for u. So simplify for that, I'm having 2 over 27, please. 27, okay. And 10 to the 3 over second power minus 1. That is my final answer. Let me write down clearly for you guys. Erase here quickly. Erase that. erase that. My answer 2/27 parenthesis 10 to the 3/2 power minus 1. That is my arc length, guys. Okay, let's move on. Example 2, finding arc length. That might be one of the tricky questions in that. So let me explain a little bit for that. After that, I want you to stop that video so you can start to check up your understanding as well. Okay, find the arc length of the graph of y equals x to the cubed over 6 plus 1/2x. So it looks like that we are looking for the arc length here, which is the smooth curve. On the interval 1/2 here to 2 over here. So remind the formula for that. Put it in A for 1/2, B for 2, square root of 1 plus. Make sure you have to derive y prime here. After that you square that, so the result will be 1/2 parenthesis x square minus 1/x square, the quantity square of course. After that, if you have to expand for that, which is here, expand, you have a trinomial. Then you really need to try to get rid of the square. So in that case, think about to make a perfect square expression. How you make that expression as a perfect square, so you can get rid of the square root of that. So this is your job to figure it out today to solving that problem. That is why I'm saying you that is one of the tricky one. So if you simplify that, you will get that expression. After that, you have to integrate that to use the FTC, Fundamental Theorem of Calculus. You have